All right, here are the notes for the Integrated Math 3 factoring review. We're going to start with some problems that we will be factoring out the greatest common factor. So when I look at this first problem, I notice that both terms have an m in it. So the way that we looked at this last year was we could write each of these terms out in an expanded form where m squared means m times m, and then you can write minus 3 times m. And basically what we're looking for is something that these terms have in common. So they both have at least one m. So that we could take out of both terms, and then we would be left with the m minus 3. So that goes inside the parentheses. Basically, what factoring is it's getting rid of a distribution or undistributing something. So if you wanted to check your answer, you could redistribute the m to the m, which would give you m squared, and the m to the 3, which would give you 3m. Okay, let's take a look at number 2. So number 2 is very similar. I could expand this and write it as a times a plus 5 times a, and I can take an a out of both terms. That's a common factor that both terms have. So that is what will go in front of my parentheses, and then anything that's left that they did not have common goes inside the parentheses. So we would have a plus 5. Okay, let's take a look at number 3. So on number 3, we have coefficients on both of our terms. I've got 2 and I've got 12. I know that 2 goes into 12, so when I write this out, I'm going to write it with a 2 in both terms. So the first term I can write is 2 times v to get the v squared. And then I'm going to write 12 in terms of 2 also. I'm going to write it as 2 times 6 times v. So both terms have a 2 that I can take out, and both terms have a v that I can take out. So 2v will go on the outside of the parentheses, and then what I have left is v plus 6 that will go on the inside. Okay, there's one more of these. So let's take a look at number 4. Zoom in just a little bit. So I'm going to look at my coefficients first, 6 and 24. And I want to think about, does 6 go into 24? Is there a common number I can take out of both? And 6 does. So when I write the 24, I want to make sure that I'm going to use the 6. So for this part, we'd have 6 times n, and then I have my minus, and I'm going to write 24 as 6 times 4 times n. So 6 is the greatest common factor of 6 and 24. And then we also have an n in common for both of those. So since those are in common, we're going to put that on the outside of the parentheses. And then what's left is we have n minus 4. So on the first 4 problems, basically, this was the greatest common factor is what we were doing. And I'm going to draw a line just kind of separating those first 4 problems from the rest of the page because they are different. This should be the first thing that you check for when you need to factor, is if there's a greatest common factor that you can take out. And to see more examples, look at last year's notebook. We did a full D that had many, many examples. This is just a small review. Okay, so let's zoom in on number 5. When I look at number 5, I notice that I now have 3 terms, and there's nothing in common for all 3 terms. These both have an x, those could both divide by 4, but there's nothing that all 3 terms have in common. So this is where we started to learn some shortcuts last year. So this is what we would say of the form x squared plus bx plus c. There's 3 terms, it's a trinomial, and there's no coefficient in front of the x squared. It's just 1. Okay? So we learned a trick for this last year, and we started off with some puzzles. where you would take the c term, the last term, and put it on the top of an x and the 8 on the bottom. And what we're doing is we're looking for two numbers to put here that multiply to make 12, that add to make 8. So let's think about that. Numbers that multiply to make 12, that add to make 8. So the only numbers that make that work is 2 and 6. And those are the numbers that we are going to use to factor this. When we factor this, it's going to factor into two binomials. And because I have x as my variable here, I know I will have x and x. That's where your x squared comes from. And then this is positive 2, so I put a plus 2, and positive 6, so I put a positive 6. And if I were to distribute all of this out using the FOIL method, I would get x squared plus 8x plus 12. This is one of the tricks that we discovered last year. Okay, let's take a look at number 6. So number 6 has the same format. We just have an n instead of an x, but still the three terms with nothing in common. So if we set up our puzzle, this time we're looking for numbers that multiply to make 4, that add to make negative 5. So I know that I'm dealing with a negative and a negative, because when I multiply them, those negatives would cancel to give you a positive 4, and when I add them, I'm getting negative 5. And the numbers that would make that work would be negative 1 and negative 4. So when I set up my two sets of parentheses, my variable's n, so make sure that I'm putting n's in there, and then I have minus 1 and minus 4. All right, let's take a look at number 7. So on number 7, same kind of situation. We're going to make our little x, and we're looking for numbers that multiply to make negative 54, that add to make negative 3. This one's a little tougher because they're both negative. When they're both negative and you're multiplying, you know that one's going to be positive and one's going to be negative. So if we think about the numbers that multiply to make 54, you can come up with 6 and negative 9. They multiply to make negative 54, but when I add them, I get negative 3. So these are the numbers that are going to go into my parentheses. So we set up our parentheses, our variable's n, so I'm going to make sure I put that in there. And I have positive 6. When I put that in, that's plus 6, and negative 9 becomes minus 9. Okay, there's one more of these. So let's take a look at number 8. So if we do our little puzzle, we're going to multiply to get negative 27. We're going to add to get positive 6. So because we're multiplying to get a negative, we know one's going to be positive and one's going to be negative. And it's going to have a difference of 6, since when you're adding a positive and negative together, they'll cancel out a little bit. So to do this one, we would have positive 9 and negative 3. If I multiply 9 and negative 3, I get negative 27. When I add them, I get positive 6. So p is my variable this time, so I'm going to make sure I start off with p's, and then here's my numbers that are going to go in. So positive 9 is plus 9, and negative 3 is minus 3. And as I said before, if you wanted to check this, you could use the FOIL method to distribute these all out, and you should get p squared plus 6p minus 27. That's a good way to know if you made a mistake. All right, the next two examples are not altogether different. We did an entire section on difference of squares last year, but for the sake of this review, I'm just going to treat this like it was one of the others. There's no number in front of the x squared term. The term in the middle is missing. So what we're going to do is we're going to rewrite this. You get where you can actually see what I'm doing. This is the one I need to be looking at. So we're going to rewrite this as x squared plus 0x minus 25. So we're just writing in that middle term that was missing as 0. So I'm multiplying to get negative 25, but I'm adding to get 0. So you know that these numbers have to be opposites if they're adding to be 0. So it would be 5 and negative 5. So this would be x plus 5 and x minus 5. And those are conjugates. We've talked about conjugates quite a bit. When you multiply them, the outer and inner terms cancel, and that's why that middle term is missing. So let's look at 10 now. So same situation, we could write this as x squared plus 0x minus 9. So we would be multiplying to get negative 9 and adding to get 0. So these again would have to be opposites that multiply to make negative 9, so that'd be 3 and negative 3. So you'd have x plus 3 and x minus 3. And this is the pattern that we used last year when we talked about differences of squares. And we did some that were tougher that did have coefficients on the beginning. You can look at last year's notebook to see more examples of that. Okay, let me zoom out for a second. We are going to draw a line before we get to 11 and 12 to show that this is a little bit different. The thing that makes 11 and 12 different, if you look at the first term, is there is a coefficient that is not 1. And that changes everything. That means that this shortcut up here is not going to work. And if we check, there's no common factor that could come. The 5 and the 20, maybe I could take 5 out of, but 52 wouldn't. So I can't use a common factor there either. So last year we experimented a little bit and came up with a shortcut for these. And there's a process that I'm going to write as we go down the side. The first step is called slide, which basically means you're going to take the first coefficient, that 5, and we're going to slide it down to the end and multiply it by this 20, and we'll rewrite it. So I'm taking that 5 off the beginning, so m squared minus 52m plus 20 times 5, which would be 100. So next to the slide you might write 5. So we slid the 5 down there. Then the next step is we're going to factor what's here. So you could make your little x like we did before. We're multiplying to get 100, and we're adding to get negative 52. So if we set this up, we have our parentheses with our m and our m. We're multiplying to get 100, and we're adding to get negative 52. Since we're multiplying to get a positive and adding to get a negative, we know that both of these are going to be negative. And it's going to be negative 50 and negative 2, because if I multiply those, I get 100. If I add them, I get negative 52. So I'll put that in here, m minus 50 and m minus 2. Now, this is not my answer. If I multiply this out, I would get this, but not what my original problem was. So it's not exactly legal to take this 5 and multiply it over here. It's a trick. So we have to get rid of it now. So our next step is to divide, and since what we multiplied by originally was 5, we're going to divide by 5. So you're going to rewrite this, and you're going to take both of these numbers that we came up with and put them over 5. Divide by 5. And then if you can reduce any fractions, you'll do that. So the 50 divided by 5 we can definitely reduce. This would be m minus 10. The 2/5 does not reduce, but we're also not going to leave it in there. The last step, for any fractions that did not completely go away, there's a step called bottoms up, which basically means you're going to take whatever is on the bottom of this and you're going to move it up in front of your variable. So this becomes 5m minus 2, and we keep this as m minus 10. And this is our final answer. This is the one that if you actually multiplied everything out using the FOIL method, you would get the original 5m squared minus 52m plus 20. So sometimes they call this the slide, divide, bottoms up method. I like to put a couple more steps in there about factoring and reducing because they're important also. Let's do one more of those. Number 12, we're going to start with slide. So you start with the 7 that's on the beginning, and you're going to slide that down to the end. So we're sliding the 7. So we'll rewrite this. We're taking the 7 off the beginning, so that's just n squared. I still have minus 13n. And then this will be plus 6 times 7, which is 42. So that's our first step. Then we're going to factor. So this is using our little x method that we had before. It'll multiply to make 42 and add to make negative 13. So I know these are both going to be negative since it's adding to make a negative and multiplying to make a positive, which would mean the negatives canceled. So to get the 13 and the 42, we'd have to use negative 6 and negative 7. So we would make this n minus 6 and n minus 7. So that's your next step. And since it wasn't really legal to multiply that number by 7, now we have to get rid of that. We're going to divide both numbers by 7. So I'm going to rewrite this as n minus 6 over 7 and n minus 7 over 7. And then anything that can reduce, simplify those fractions, we will do that. So the first one, I can't do much with. It's just 6/7. But 7 over 7 would divide and just leave me with 1. So I can rewrite that as n minus 1. And then if there's any fractions left, the last step is to bottoms up. So we'll take this 7 that's on the bottom and move it up in front of the n. So you'll have 7n minus 6 there and n minus 1 there. And that's it.